We're talking here about precipitation reactions. I'm going to illustrate a couple of these, and before I actually show what the actual demonstration is, let me put the reactions up first. We're going to have lead nitrate, and I'll already tell you it's aqueous. And then we're reacted with the potassium iodide. And I'll put the products below here so there's enough room. Now, so these two are going to be aqueous. So now our goal is to figure out what will the products be when we're done. We know this is a double displacement reaction. Double displacement reactions, the cations switch places. All right, so we should have the lead going with the iodine and the potassium going with the nitrate. How do we know what charges they are? Well, just like we've learned before, when you back the charge up, we know the lead's going to be +2, nitrate's going to be -1, potassium's +1, iodine's -1. So we're going to have lead iodine and then potassium nitrate. Now we're talking about solubility rules with this, so we should be able to predict what states will be the two products, looking at our solubility rules. Right now I currently have an overhead of this on here. It's not obviously on screen here, but they have the list in front of them. So, for lead 2 iodide, what are we going to get? Let me put the 2 over here a little better. So what state should it be? Yeah, the back. Solid, okay. So putting an S there. Potassium nitrate. Aqueous. Q. All right, so now we have to balance this. Or we check C. Well, of course it's not. So what should we put where?
A 2 in front of each of the Ks.
Where?
In front of each of the potassiums.
Okay. Got 2 there and 2 there. All right, so we have 2 potassiums. Lead, there's 1 here and 1 there. 2 nitrogens, 2 nitrogens. 2 I's, 2 I's. 6 oxygens and 6, and we're all happy and content with that. All right, so let me actually do the reaction here. All right, so I'll put the lead nitrate in this test tube first. Okay. And before I actually add the iodine, which is in this brown bottle here, what do we think the color is going to be? It won't be white. I'm going to bore you with just a paltry looking white color. What do you think it'll be? Blue, pink, yellow. Well, let's see. Let's see what happens. All right, so add it. Yellow. There we go. That's 5 points. Yay! All right, so that's what actually a lot of times people laugh at it, but a lot of people became chemists because of the pretty colors. For myself, it just was well, something like that, 2 colorless solutions I had to get. How would I get yellow? And just we want to know why. All right, so we get a yellow color there. Let's put yellow with this one. You're not going to have to ever know what the colors are. I don't expect you to know that, but you should go to this. All right, so that's one example. I have another one, but any questions first on how I got this? Okay, it's all solubility rules and knowing about double displacement reactions. All right, the next one. Again, I'll give you the states for the reactions. So I have silver nitrate and potassium chromate. Silver nitrate I have is in one brown bottle here, and this is the potassium chromate. So again, double displacement reaction. This is a polyatomic ion here. They have a -2 charge, the chromate. And we know silver has +1, nitrate has -1, potassium has +1, just like above. So again, the silver is going to go with the chromate, potassium is going to go with the nitrate. All right, so So the question goes back to the audience once again. What are we going to get for this one, state-wise? Aqueous. The other one?
Aqueous?
No, I don't know if that one's on that list, is it? It may not be. It's not on the list. Okay. This one's actually going to be a solid. Sorry, I thought I had that on the list here. You won't have to know it. It's not. If it's not on the list, don't worry about panicking about it. Anyway, so this is what we have. Let's check and see about the balancing situation. So if it's not balanced, which is the case here, it's not balanced, so what do we have to do? What do we add where? Yeah. Go ahead, Casey.
2 in front of AgNO3 and then 2 in front of KNO.
Okay. All right, so let's check. We have 2 silvers, 2 nitrogens, 2 nitrogens. We'll get to the oxygen in a minute. 2 potassiums, chromiums, 1 of each. Oxygens should come out in the wash. We have 2 times 3 is 6, plus 4 is 10, 6 and 4 is 10, so that's set. All right. And I'll put the silver nitrate is actually a colorless solution. The dropper itself is a little bit black, but that's all right. It's nothing to worry about. And then I'll add the potassium chromate. But again, now this won't be yellow, and it won't be white. So what do we think now for color?
Blue.
Blue,
Pink.
pink,
Red.
red,
Brown.
purple with pink polka dots. Yeah, that would be interesting there. There we go. We got this tomato juice looking color, so reddish type color. Now I'll let these sit here in the beaker, and eventually they'll separate out at some point. The best way to really separate out the precipitate from the solution itself, or the solvent, not really the solution, would be to use a centrifuge, which we'll be using next time.